Good afternoon and a very warm welcome to all. So today in methodology we are going to discuss about anaerobic cultivation apparatus. Before that we can briefly describe about anaerobes. So what are anaerobic microorganisms? These anaerobic microorganisms are widespread and very important, and they do not require oxygen for growth. Often they are extremely toxic. This oxygen is extremely toxic for the anaerobes. Now obligate anaerobes. It can be defined as the microorganisms which are unable to utilize molecular oxygen for growth. A further differentiation is possible based on their relationship to the presence of oxygen. Next is aerotolerant anaerobes. They are only slightly inhibited by significant level of oxygen in the atmosphere. For instance, Clostridium intestinale DSM 6191T. It is a strain number. It can grow well on the surface of the agar plates incubated in air at atmospheric pressure. The other extreme is represented by strict anaerobes, which die or immediately stop growing when they are exposed to low levels of oxygen. So, it is therefore important to retain anoxic conditions during all steps of handling these type of microorganisms. Most strict anaerobes require not only the absence of oxygen to initiate the growth, but also a redox potential below -300 millivolt, which can only achieved by the supplementation of media with reducing agents. Then only redox potential can be established. So there are certain recommended vials for culturing strict anaerobes. So what are these recommended vials? Suitable containers for pre-reduced media are an important prerequisite for the successful culturing of strict anaerobes, and for this purpose a special glasswares has been developed, and that glasswares enables the easy use of completely gas-tight closures. Of crucial importance is the material of rubber stoppers. Only stoppers or septa made of butyl rubber can effectively prevent the permeation of air into the vial. Nevertheless, a repeated puncturing of stoppers with injection needle could make them become permeable to oxygen. As a result of this, the thicker the stopper, the more often it is possible to reuse it without the loss of impermeability. So we are telling about the stoppers. Now, two types of vials are commercially available for anaerobic culturing. That is, hung gauge type tubes are closed with a flank type butyl rubber septum and a screw cap with 9 mm opening. So I will show the types of tubes. Hung gauge tubes is a type of vial. Another one is bulk type tubes, which are more stable than hung gauge type tubes, and these are mostly recommended. If an overpressure of 2 to 3 bar can be expected during culturing, they are closed with a thick butyl rubber stopper, which is held in place by sealing with an aluminium crimp. For sealing and removing of this aluminium crimp, special devices are necessary. So this pre-reduced media can be stored in both types of vials at room temperature in the dark for several weeks without becoming oxidized. So there are certain cautions we should remember. Some microorganisms produce a considerable amount of gas during the growth. Example, Clostridia by fermentation. The formed gas can lead to a substantial overpressure during the growth in closed vials. So the strains which are known to accumulate the gas during the growth should be incubated in the vessels that are filled only up to 25% with liquid medium. So the organisms which have higher pressure should be incubated up to 25% in liquid medium. In addition, the cultures of fast growing strains should be vended at least on the daily basis to avoid overpressure and wear protective goggles during handling of glass vessels that might have overpressure. So these are the precautions to be taken. And this is the Hungate type of type tube with screw cap and a butyl septum. Another one is Balch type tube with butyl rubber stopper and aluminum crib seal to hold the stopper in place. A crimper is necessary for sealing the vial. Next type is gassing of the media and cultures with oxygen-free gas. So there are certain types of culture medias in which apart from or other than oxygen, other gases are introduced other than oxygen. When the vials of pre-reduced media or anaerobic cultures are opened, a constant flow of oxygen-free gas over the surface of the medium is necessary. Why? To avoid the exposure to oxygen. Because the used oxygen-free gas should have the same composition as that used for media preparation. So they recommend to use oxygen-free gases of high impurity. Normally, these oxygen-free gases of high quality do not require an additional oxygen removal system. So it can be used directly for culturing broad spectrum of anaerobes. And this Hungate technique is based on the use of gassing cannulas, etc. So this is the assembly of the cannulas used in Hungate technique for aseptic gassing. Next, about anaerobic jars. Actually, this anaerobic jar system, it is a system to provide anaerobic environment to bacteria. And different compositions are polycarbonate jar, Petri plate carrier, anaerobic indicator plate, anaerobic gas bag. These are the 4 important compositions. Principle. Anaerobic jar system, it is very simple to use and it's system for generating anaerobic environment necessary to cultivate anaerobic microorganisms within sealed jar. System consists of polycarbonate jar and it is a multiple use self-contained system and it works on the principle of evacuation and replacement. When the air inside the chamber is evacuated and replaced with a mixture of gases, polycarbonate jar consists of the jar of stout glass with a tight fitting metal lid. So, the system consists of a polycarbonate jar and it is a multiple user self-contained system. It works on the principle of evacuation and replacement and they are replaced with a mixture of gases. And this polycarbonate jar consists of a jar of stout glass with tight fitting metal lid. The lid can be clamped airtight with a screw and is fitted with 2 tubes with taps, one for introduction of gas inside, another as outlet for vacuum valve. Next is about Petri plate carrier. This carrier can accommodate up to 10 Petri dishes of 100 mm diameter. Next is culture tube carriers. So this tube carrier can accommodate 8 culture tubes. Next is anaerobic indicator tablet. It is a sachet which containing a tablet prepared from resazurin. It is used for checking anaerobic atmosphere in sealed containers used for incubation. The color change from pink to purple indicates anaerobe conditions. Next is anaerobic gas pack. Anaerobic gas pack, it is the method which is used in the production of anaerobic environment. It is used to culture bacteria which die or fail to grow in presence of oxygen, and they are used to produce an anaerobic culture in microbiology. One sachet of anaerobic jar pack is used for 3.5 liters per day. So they are used in the anaerobic culture in microbiology. One sachet of anaerobic gas pack is used for 3.5 liters of small jar. For large jars, 3.5 liters use, such as larger than 3.5 liters, use 2 or 3 sachets in proportion to the vacuum base. So, the jars larger than 3.5 liter use 2 to 3 sachets in proportion to the jar volume. Now, next is the instructions for use. Place the petri dishes in the carrier, which should be of the vented variety to aid gas transfer. Between the interior and exterior of the plates, insert anaerobic indicator tablet into the smaller upper clip in the plate carrier. Put the loaded carrier into the polycarbonate jar. Remove the paper sachet from the foil bag. Do not open the paper sachet and immediately place the paper sachet into an anaerobic jar and close the jar lid. Do not have to add water or use a catalyst. Place the lid fitted with accessories in the jar after making sure that silicone O-ring is correctly placed on the jar. Apply the three-finger clamp and screw down until tight. A metal accessory named as vacuum chunk has been used for evacuation, replacement, etc. And the technique to enable first vacuum to be downed. Fit the vacuum chuck connected to the vacuum line to the wall marked as vacuum and the open of the chunk firmly down on the vacuum valve preparation. So, fit the vacuum chunk connected to the vacuum line and press it. Open end of the chunk firmly down onto the vacuum valve body. Screwing will damage the sealing rubber washer and cause the chunk to leak. So, evacuate the system to about -30 mm of mercury. After use, simply lift the vacuum chunk straight away from the vacuum valve in order to disconnect it. Observe the pressure gauge. A leakage in the jar will be detected at this stage because the vacuum reading will not remain constant. Attach the pressure chunk connected to the GERD supply to the vacuum. So, attach the pressure chunk connected to the gas supply to the pressure valve of the jar. Run the gas mixture into the jar. Pressure is 0. Disconnect the pressure chuck. Observe the pressure changes in the jar. Release more gas mixtures to the jar until the gauge reads 0. Disconnect the pressure chunk. Incubate the jar. The anaerobic indicator tablet will remain pink in the jar, indicating anaerobiosis. Any kind of leakage leading to anaerobic condition will turn the color of the tablets to produce. Next is about precautions. The jar is designed to be used with anaerobic gas packs and must not be used with gas. So the rest of the part can be described in the part